All right, so here we are at week 3 of Kubernetes the Hard Way, walking through all the various labs and doing it all live. My name is Jamie Duncan. I'm a customer engineer at Google Cloud. In the first week, we went through a lot of prerequisites. We installed some applications to create TLS certificates and sign them and actually create a certificate authority. We provisioned our infrastructure. We provisioned some networking components and some firewall rules, and we provisioned an IP address that we're going to use as a load balancer, which we actually are going to be setting up this week. In the second week, we created a whole bunch of configuration files and shuffled them across to various servers. And we also we deployed or bootstrapped etcd across our control plane nodes. And etcd, if you don't remember, is the database that Kubernetes uses to store information. etcd shorthand version is it's a key value database that has a RESTful API in front of it. Pretty simple stuff. So this week, we're going to start tying all this stuff together. And this is the week where things get kind of fun. We're going to be taking all of those configuration files, all those certificates across all of those nodes, and we're actually going to deploy the Kubernetes services. So we're going to bootstrap our control plane. We're going to bootstrap our application nodes. And at the end of the session, we're actually going to have more or less a functional Kubernetes cluster, which to me is pretty cool. So this is the week where the rubber and the road get together and do fun stuff. So let's get going. Last week, we started using tmux to synchronize commands across all of our control plane nodes or all of our application nodes at once. We're going to be using that again today. I did save some time, a little infomercial style, and I have my tmux sessions for my control plane nodes and for my application nodes up and running already. So I'm not going to walk back through that. If you need a tutorial on tmux, it actually is in the lab docs. I'll just pull the lab docs up real quick. How to open up the panes, connect to the system, synchronize the commands across all the panes inside tmux, make them all nice and even and pretty and vertical, all of that fun stuff. So that's all in there. I've already done it to save us some time because we have a lot of work to do today. So let's get going. We're going to start out on our control plane nodes. You can see here I'm connected to all 3 of them simultaneously. I'm just going to bring these over into my main window so I can see and type a little better. All right. Scrolling down through the docs, we're at bootstrapping the control plane. And again, we have the tmux information in there if you need it, if you don't remember it. But we're not going to do that on the live stream. I've already gotten that done. So connect to our control plane nodes. That's finished. All right. Now we need to start making some directories and pulling down some binaries. So sudo make dir etc kubernetes config. Done. Easy peasy. All right, we're off to a good start. Now we're going to pull down the various binaries that we need. And we're not going to build these from source because we don't really need to, but we're going to pull down the pre-built binaries for Linux. We're going to be pulling down the Kube API server, Kube controller manager, Kube scheduler, and kubectl onto our control plane. It's not there yet. It's on the other nodes. It's on our Cloud Shell instance where we actually used to create all those configurations last week, but it's not actually on the controller nodes. So we need to put it there. So this is a whole bunch of wgets. And it's going to take just a minute or so for it to pull down to all of them. Done and done. All right, and then we need to move them around to the right spot. We're going to make all of them executable because you have to be able to execute things. Easy enough. I'm going to clear my screen to keep it up towards the top. And then we're going to move all of these into user local bin. User local bin is just a binary directory on our default path. All right, that's done. Now we need to actually configure these things. And this is where things start stitching together. We know we have certificates for all these services. We know we have config files for all these services. And now we have binaries for all these services. So we're going to create these config files, put them all in the right place so they can reference one another, and then turn around and start them up using systemd. So for each of these services, we're going to create these config files, put everything in the right place, and then turn around and create a systemd unit file like we did for etcd so we can start the service when the system boots. So let's go ahead and get that done. So we're going to start out with Kube API server. And if we take a look at this command, sudo move the certificate authority, key and certificate, and then the Kubernetes key and certificate that we created for Kube API server. And then the service account key and certificate, and that encryption config.yaml file that we created last week. And there was a typo last week, and I think I fixed this in the docs. Last week when we moved encryption config over to the servers, I fat fingered it, and the command put it on the application nodes, the worker nodes, not on the control plane nodes where it actually needs to be. So I think I fixed that in the docs, but you may have to go back and grab that file, grab encryption config.yaml from your Cloud Shell instance or from wherever you're deploying this stuff from, and move it to your control plane nodes. If it's not there, if it's not in varlib Kubernetes, then Kube API server will not start. Oh, forgot to make a directory. Another little typo. All right, so all that is in varlib Kubernetes now. Now we're going to need to reference the internal IP address in our systemd unit file. So we're going to get that by hitting the G-Cloud or the Google Cloud metadata server. Make sure that worked. All right, we have that. Now we're going to create the systemd unit file for Kube API server. And if you'll look, and we're going to walk back through these in a little bit. We're going to take a little deeper look at them. But Kube API server, and I'll hop over to the docs page where I'm at. Kube API server has a lot of parameters. And just to take a look, API server count is 3. That means we're going to run it on each of our control plane nodes. Authorization, the address to bind to the client CA, which is that file we just moved in. The etcd CA, which is the CA, using the same CA, the cert file, the key files, the servers where these are all going to live. All the configurations that Kube API server needs, how to talk to the kubelet certificate authority, the kubelet certificate client, the kubelet certificate file, the kubelet certificate key, or all those things we created over the past couple of weeks. This is where we reference all of them. So let's go ahead and create the systemd unit file, which is easy enough. But just going through all these parameters, Kube API server has a ton of parameters that it can use. All right, that's it. So Kube API server is ready to start up. We're not going to start these services just yet because we need to get everything put together and in the right place. Kubernetes services, especially on the control plane, if you try to start one without its dependencies running, I can get a little annoyed and go into just sort of a crash back off where it will wait a long time before it starts to restart again. So we're going to start all these things up at once. So we've got API server ready to go. Let's go ahead and configure Kube controller manager. All right, here's the config. The first step is moving that kube config file that we created last week, and I'll go ahead and clear my screen. That kube config we created last week to varlib Kubernetes. And that's all it needs. So it needs that and a systemd unit file. So the controller manager, all the configurations it needs are in that kube config file. We then go ahead and create our controller manager config file. And it doesn't need all of the parameters that you need on API server. We're really just telling it what the cluster name is, where their certificates are, the certificate to go ahead and sign things, because it actually signs all these services and verifies everything. So where the CA is, the root CA, service account, private key, that service account key that we created, because the controller manager manages all these service accounts. All right, so let's go ahead and get this guy created. All right. Now the next control plane service we have to create is Kubescheduler. And this is, that all too famous scheduling algorithm that tells Kubernetes where to put the next pod. All right, so that Kubescheduler kube config file goes in place. We also need a Kubescheduler configuration YAML file, and that needs to live in etc Kubernetes config. You see the type, the kind is a Kubectl configuration. So this is an actual object that is managed by a controller inside Kubernetes. And we tell it where to look at its kubeconfig. So varlib kubernetes kubescheduler.kubeconfig, which is the file we just moved over. So this is how Kubescheduler knows where to look for its configuration file. And that's all done. And then it needs a unit file just like everything else. This one, we just tell it where its YAML configuration file is. I'm going to clear this screen. So in this, and for Kubescheduler, we just have to tell it which version to use, where the config file for its YAML is, which just references that kubeconfig file that we created. So pretty simple service here. So Kubescheduler, all of its magic is internally. And those are our control plane services. So we're going at a pretty good clip. We've just configured Kube API server, Kube controller manager, and Kubescheduler. We've put all the configurations and certificates and keys in the right place. We have we've created systemd unit files for all of them. And now we're ready to get these things going and make sure they're functioning right. So systemctl daemon reload, just to tell it about its new unit files. Go ahead and enable all these things to start at boot. All right, all those symlinks got created. Now, Kube API server does go through a little bit of internal startup. It may take about 10 seconds for it to be fully up and running. So we're going to go ahead and start all these services. So systemctl start, Kube API server, Kube controller manager, and Kubescheduler. All right, we're going to give it a couple of seconds, and then we'll check the status of Kube API server. Because if he's running, everything else should be up and running in good order. Clear. All right, so we see here active, active running, and active running. So we have Kube API server up and running on all three of our control plane nodes. Awesome. So we're in good shape. Excuse me. All right, now we start to get into some of the other fun stuff. So we're going to be using a load balancer, a load balanced IP address from Google, from GCP. That means we need to enable health checks on our control plane nodes so the load balancer knows that the nodes are healthy. So that's the /healthz endpoint. And we have to turn that on. That's not served out by default. So we're actually going to install Nginx on our control plane nodes and create a config where it will grab that data from the Kubernetes API server and make it available to our load balancer, our load balance config inside Google Cloud. So apt-get update. This will just take a second. And then install Nginx. And again, this just takes a second. Done and done. Now, if we look at the configuration file where we are, kubernetes.default.service.cluster.local. We're going to listen on port 80, so this isn't going to be encrypted at all. The server name is going to be that long default.service.cluster.local. The location is /healthz, healths, however you want to pronounce it. And it's just a proxy pass to the Kube API server /healthz. And that we're to talk to it, we're going to actually use the CA, the certificate that we created earlier, our root certificate. So we'll go ahead and get this all created. All right, so we have our config. And then because this is Ubuntu, we have to do the sites available, sites enabled thing. So we will move our config to etc nginx sites available. And then we symlink it to our sites enabled directory. Not my favorite part of, not my favorite feature in Ubuntu and Debian, but it's the way they do it, so it's the way we're going to follow. And then we will restart Nginx just to make sure that it's going. And we'll go ahead and make sure that it's also enabled to start at boot. And then let's go ahead, if I could type systemctl status Nginx. There it's active and running on all 3 servers. Curl. And I'm just going to see if this works. I didn't actually try this. No, because it's curl. Let me grab that actual URL. And I don't know if this is going to work or not, but we're going to give it a try. Nope, can't resolve the host name, but we're going to take care of that in a couple of minutes. All right, where it will work from, and it just popped into my head that I wondered if that would work or not, and it didn't. So kubectl, since we have kubectl installed on all these servers now, we can see the component statuses because we actually have services up and running now. We can see here the scheduler is healthy, the controller manager is healthy. Obviously, the API server is healthy because we just used kubectl to communicate with it. And all 3 etcd hosts are healthy. So we have a healthy control plane running now, which is awesome. Now we can also make this command work. And what I forgot and what's actually in the docs is you have to pass it a header with the host information. So we'll add the host header and then hit localhost/health. And that host header will make Nginx pass it to the name-based virtual host that we configured for it. And now that works just fine. So we got our 200 OK. We got all of our stuff alive. You see that OK at the bottom is what the load balancers are going, the load balanced IP address is going to look for to make sure that everything is happy and healthy for our control plane to have the load balanced IP addresses. So kind of fun. All right, now what we need to do, and we're only going to do this on one of them, so I'm going to turn off the synchronization from tmux. Set W. Synchronize, if I could type today, synchronize panes off. So now I'm only on controller 0. Any controller will do. But what we're going to do here, and this is in the communication from API server to the kubelet, we're going to create a role and a role binding so the API server can actually talk to the kubelet part of the API. What this is going to do, and I'm going to switch back to the docs because it's not going to look good on the terminal screen. So kubectl apply. And then we'll tell it to use our admin.kubeconfig, which is our service account, our system admin user. This -f with the dash is telling kubectl to take the input from standard in. So take the input from that pipe, which is what's going to echo out all the stuff below, and apply it like you were looking at a file. So cool. So annotations, this is an RBAC authorization. Labels, bootstrapping RBAC defaults. The name is important. System, Kube API server to kubelet. Rules, API groups is everything. Resources, nodes/proxy, node/stats. So all of the nodes endpoints, which are where all the information around all of the nodes live. And we will be able to run a get or a post or a pull or everything. And what this is doing is letting Kube API server talk to the part of the API that is populated by kubelet running on all of the application nodes. So because this is actually going into kubectl, it's going to be created as part of the API server. We don't have to run it on all 3 hosts. We just have to create it on one, and it'll propagate all those changes out. So we've created a cluster role, and the next thing we have to do is create a cluster role binding. And that is in here as well. So we'll take the role, we'll bind it to a user, done and done. Go ahead and clear this up. All right, and hop back to my terminals for the control plane, and cluster role binding was created successfully, as was the cluster role. All right, so now we've got a control plane up and running. All of our services are running. I can access the services locally by passing that host header to check the health. I can also run Kubectl, and as long as I specify my certificate, I'm able to actually talk to the Kube the Kube API server through Kubectl. But I want to be able to access all of this stuff from my host. I want to be able to access all this stuff from anywhere, because that's what I'm supposed to be able to do. I don't want to have to SSH into, a control plane node to have to do work. So we're going to create our front end load balancer, and then we're going to set up the RBAC. We're going to set up a kubeconfig to let us talk to Kubectl talk to our cluster using Kubectl from somewhere that's not inside our cluster. So the first step there is creating our front end load balancer. And this doesn't happen on the control plane nodes. This actually happens on the host where we bootstrapped everything. This works on the host where you've created everything. So I'm going to get out of our tmux session, Control B, kill session. And this will kill all 3 sessions and drop me back to my Cloud Shell, just to make sure everything still works. gcloud compute instances list. I should still see. I'm going to have to run the gcloud init thing again. All right, so this is going to take a second. This didn't happen yesterday, but I don't know what the difference is. Like, I don't quite understand when sessions do and don't persist using tmux and jumping in and out of stuff. Kubernetes The Hard Way, Duncan prod, and I will tell it to use the right region. So all of that should be squared away now. gcloud compute instances list. All right, now I'm up and running. I have all of my stuff listed out. So to create my front end load balancer, I need to grab that public IP address that we provisioned earlier. Kubernetes public IP address, and I can use the gcloud command, the SDK, to do that, just to make sure that worked. All right, there's my public IP address. All right, so I need to first create a health check using the gcloud SDK. gcloud compute create health checks. And here I'm giving a description. I'm telling it the host to use. So kubernetes.default.service.cluster.local, which I know is long. And the request path, I'm just telling it to look for that /healths. So done. All right, then I need to create firewall rules. And this one had to do a little digging on because of the ranges. Go ahead and clear this out. gcloud compute firewall rules, create, allow the health check. Because of the way Google's infrastructure is deployed, my health check requests could come from anywhere in any of these IP ranges. It's a big, giant cluster of things. So it's not always going to be coming from the same place. So my health check could come from anywhere in these IP ranges. And this is in the Google SDK documentation. I just never experienced it before and had to go look it up. So it's going to create my firewall rules to allow the places where health checks come from to hit my cluster on my network. All right, I then create a target pool for my health check. And then in that target pool, I add controllers 0, 1, and 2. All right. And now what I have to do is create a forwarding rule to allow everything to work on port 6443 and all of that fun stuff. So we'll take a quick look at this one. gcloud compute forwarding rules create Kubernetes forwarding rule. So the address is my public IP address for port 6443. For the region is my default region. The target pool is the pool I just created. So what this is saying is I'm creating this rule that says if I hit the public IP address on port 6443, forward it to the same port on my one of my target pool nodes, which is controller 0, 1, and 2 that I just created. And this actually takes a second or two for it to work. All right, so that got created. Now let's verify all of this works. All right, and here's a little typo I found. I don't know why this is being escaped out, but it's being escaped out. So curl using my CA certificate, ca.pem. So using the cert for Kube API server, curl my Kube API server, my public IP, so my load balanced IP address on port 6443/version. And that error, ran into this before. I'm not quite sure what's up with the certificate. Oh, yes, I am. cd Kubernetes the hard way prod. It's easier if I run the command where it can reference. There we go. So now when I'm in the directory where my actual CA certificate exists, I'm able to use that certificate to go and hit my load balanced IP address on port 6443 and pull up the version information, which I'm running Kube 1.18.6. So I'm able to go through my load balanced IP and talk to my Kubernetes API server at this point. Pretty cool. And I've got health checks for everything so that I actually go and look at those health endpoints and pull all of that fun stuff out. All right, so now I have a Kubernetes control plane. So the next thing I have to do is add application nodes to it. So let's go ahead and get that going. I told you there was a lot of work going on in this one. So I'm already connected up to all 3 of my worker nodes or my application nodes. We're going to have to install some dependencies here. Contract, IPset, and SOCAT. These are all useful if you're debugging. SOCAT enables you to do port forwarding. So I can actually use kubectl port forward and forward ports from a specific pod or a service over to a local host running locally, and SOCAT does all that for me. So running sudo apt-get update. That didn't work there. Oh, because I'm connected to the wrong. Let me clear out of this. If you'll notice what I did, I connected to worker 0 twice. So we'll turn off synchronization. Worker 2. All right, then I'll turn synchronization back on. Now I'm on 0, 1, and 2 as I should be. So I'm going to run that sudo apt-get update just one more time to make sure. See, number 2 is going to take a little longer than the other 2. All right, but that's all done. Then we'll install our software. Now on these nodes, Kubernetes does not work if swap is running. It's just one of the reasons the way the application's built. These hosts do not have swap, but just to confirm, We'll make sure swap is disabled. You see there's no output. If we'd seen any output there, we'd actually have to go in, turn off the swap, go into the /etc/fs tab, remove any references to the swap partition, and then actually go into and mask in system and using systemd and actually mask all of that stuff off so swap didn't try to get turned on when you booted the server. All of that is documented. There's a link in the docs under step 3 here. Swap is enabled, disable it, and then there's some additional steps you have to go through. Luckily, these aren't enabled by default, so we're in pretty good shape there. All right, so our nodes also need some software. So the first thing we're going to do is pull down containerd. Containerd is our container runtime. Think of it sort of like Docker. Then we will untar it into, we'll go ahead and make that directory, make dir containerd. And in Kubernetes the hard way, it has moving the containerd binaries into /bin. I don't know if there's a practical difference there, if there's a needed difference between putting it in /bin or /user local bin, but we're going to do it. I mean, it works. It may just be that it could be just an old reference, or it could be a reference from someone else doing it. So we now have containerd downloaded and installed into a binary directory in our path. CRI-CTL is used to interface with our container runtimes. CRI is container runtime interface. CRI control. These squared away. Make it executable. Bring this up just a touch. And then we'll move this one to user local bin. All right, done and done. Now we have to install runc. Runc is just another dependency along with containerd. And we'll actually rename this from runc.amd64 to just runc. Move it over, and this is a little tedious, all of these steps. You can very easily glob this all into one big step, which is actually what the Kubernetes The Hard Way labs on GitHub do. But I wanted to break them all out into individual little chunks, just so you get an idea as for what all these different tools do. So the Cni plugins, container network interface plugins, help us work with the Cni, or the container network interface, inside Kubernetes. All right, all of those files got moved. Now we have to install Kubelet. Kubelet, again, is that sort of gateway, that interface between all of the container runtime stuff that we just deployed and the Kubernetes API server. Chmod plus X, all of these steps. It gets a little tedious, but we're almost done. And then we have to install Kube Proxy. A lot of people get confused with Kube Proxy because it has the word proxy in it. Kube Proxy is not a proxy like a reverse proxy like we're using Nginx for on our control plane. Kube Proxy runs on each node and lets Kubernetes talk to the networking stack on the node. So when you actually create a pod or create a container, it creates a bunch of firewall rules to do all the forwarding and stuff. It's Kube Proxy doing that under the covers. And you'll see here in a few minutes when we create the config files that we're telling Kube Proxy to use IP tables on these hosts to get everything configured. All right. And then we'll stick kubectl on here as well. I'm just going to do this as one big long chunk instead of 3 individual commands. All right, there we are. Now we have to configure CNI, so the network container networking interface. And if you remember in the first lab, when we actually deployed our compute nodes, we added a metadata tag or a metadata value on each node that gave it a pod CIDR value. So we're actually going to use that metadata information and store it as a variable. And the way networking works inside Kubernetes is you have one large pod CIDR subnet, which is usually like a /16 or maybe even bigger, depending on how big your cluster gets. And within on each application node, each application node is allocated a chunk of that large pod CIDR subnet. So we're using a /16 here, but each node, each worker node, each app node is actually getting a /24 for pods running on it. And the /24 is part of the /16. It gets a little weird, and if you're not comfortable with CIDR subnetting, it can get really uncomfortable. It's just kind of how the world works. The other thing we have to do is tell our CNI, our container network interface, to create a bridge on our host. A bridge is a virtual device in Linux. Linux bridges have been around forever. A bridge you can link multiple other interfaces to a bridge. So think of a bridge as almost like a very dumb virtual switch. Each host has a bridge. That bridge works at layer 2 of the OSI model if you want to get down into those weeds. But what we're able to do is when we create a new interface for a new pod, we're able to put it in that bridge, and then the bridge has a default gateway. So it's just a way for us to sort of aggregate and separate traffic on a Linux host. And we're going to I'll switch over to the docs. We're going to tell our container network interface, our Cni plugin for Kubernetes, to create this bridge, what to name it, what route to give it. So it's just got the default gateway, what subnet range it's got, all of that stuff. And then the Cni will create the bridge dynamically as needed through Kube Proxy. Also, every time we create a pod, each pod gets a loopback address or a 127.0.0.1 address. And we tell our CNI to create that for us when the pod gets created. And again, it's just a little more YAML. All right, so that is all the configuration we need to give our CNI. Next, we need to configure containerd. Let me hop back to our app nodes here. All right, so we're going to make a directory called /etc containerd. And just remember, all of this tedious work is handled for you by all of those provisioning tools that we talk about all the time. So containerd gets a config. Go ahead and clear. This might fall fit. Yeah, it'll all fit in here. So for plugins, I'm going to be using OverlayFS. OverlayFS is a copy on write file system that we use for pods for containers, or for containers in pods to be accurate. So we have a read-only file system that is the container image, and then as changes happen inside the container, we're using OverlayFS to write those changes on top of the container image file system, as well as any mount points that we have. The runtime, we're telling, when containerd needs to do something for our runtime. So if we need to create a container, if we need to destroy a container or get status of a container, we're telling it to use runc to do that. And we're telling it that our runtime type is containerd. So we're telling containerd everything it needs to know to get running. Essentially, use runc to control itself and use OverlayFS for file systems for snapshots. And then we'll create our containerd unit file. Nothing too earth-shattering inside here. Next, we need to create our kubelet configs. This is dealing with more certificates. So we'll go ahead and create varlib Kubernetes on these hosts. And we'll move our certificate authority cert, our root cert for our cluster, into varlib Kubernetes. as well as our host name key and certificate that we created way back in lab on our first session. We'll move those into varlib kubelet, and I forgot to make varlib kubelet sudo. All right, those are done. Oh, I just had the instructions out of whack. Sorry, I was running through this really quickly last night to make sure it worked. And I have that varlib kubelet command in the wrong step. We also need to move our host name kubeconfigs. Notice we're changing the name here. So when we created, we had worker0.kubeconfig, worker1.kubeconfig. On each host, we're just moving them to varlib kubelet kubeconfig. Is that host name, that unique host name isn't needed anymore. We also need to create a kubelet config file. This isn't going to fit on the screen very well. Let's hop back to the docs page. It's YAML that we're going to be feeding into Kubernetes, our kubelet configuration kind. So API version, anonymous authentications enabled, webhook enabled true. That's the way we're actually going to be communicating back up to the Kube API server. We're going to tell it where our root certificate is, how to authorize. Again, we're using that webhook command, and that's just, we're telling the kubelet that when you need to go up and connect, there are a couple of different ways it can authenticate. Webhook is most common. We're telling it what its cluster DNS is. That's that large pod cider. And then also 10.32.0.10 is one of our control plane nodes where we're getting our DNS from. We'll set up DNS next week. Resolve conf. This is a little hack. I think I actually make note of it. We're going to be using core DNS for DNS next week. We're telling core DNS to use the resolve.conf template that systemd creates on our host. And it gets a little weird because DNS is always weird. But essentially, that little config of telling resolve.conf where to get its resolve.conf template from keeps systemd and Kubernetes in line so they don't start stepping on one another and start trying to overwrite each other's config files for DNS resolution. Because if you don't do that, it gets really complex really quickly and really annoying. All right, so let's go ahead and create our kubelet config and hop back over to our app nodes and then create our systemd unit file for kubelet. Again, a few parameters that we pass it in here. We're telling it to register the node. We're telling it to use the Cni network plugins. We're telling it where its kubeconfig file lives. But nothing really earth-shattering. We're just telling it to reference the stuff that we just did. That's all done. Then we have to configure Kube Proxy. There's just so much work to get a Kubernetes cluster up and running on its own. Thank goodness for tools like KubeADM. All right, we'll move the Kube Proxy config to varlib Kube Proxy. Again, we're renaming that file. Kube Proxy also has a little bit of YAML to define how it's configured. Effectively, mostly just saying, here's your subnet. So here's the cluster CIDR. Here's the CIDR for the entire cluster, which is that big /16. And that's used when Kube Proxy needs to just configure routing and stuff. And then the rest of your configuration lives in varlib Kube Proxy kubeconfig, which references all of the CA certs and everything. And then we need a systemd unit file for Kube Proxy. Control C if I could type today. Done and done. All right. Now we're ready to actually start services. All right, so we've configured Kube Proxy, we configured Kubelet, we've configured our networking through our Cni plugins, we've configured containerd and run C, fed all of that stuff into a bunch of different configuration files, which you can, if you want, can take a little additional time and really start parsing about. But what we've done is take all those certificates we created, all those Kube configs we've created, all those binaries that we've downloaded, and we've glued them all together consistently. So let's start these things up and make sure they work. All right. And then we need to enable Containerd and Kubelet and Kube Proxy. And then we need to start the same services. So Containerd is our runtime. Kubelet is our interface for our container runtime. And then Kube Proxy is our interface for our application nodes networks. All right. Then let's go ahead and verify that they're running. Status Kubelet. All right, it's running on all 3 hosts, which means Containerd is running. If there's no container runtime, Kubelet won't start. All right, so let's get out of here. We're going to get out of our tmux session. All right. And we're going to use this command. We're going to go to controller 0, and we're going to tell it. Well, let me hop over to controller 0, control plane. All right, so here I am on controller 0, and I want to run kubectl get nodes, kubeconfig admin.kubeconfig. That didn't work. See if I did something wrong. We have our first failure. Oh, because I'm sorry. I am not on controller 0. I am on my Cloud Shell instance. So that command should fail. At least until we do the next thing. There we go. Sorry, I had a little brain cramp there. So it was failing because I'm on my Cloud Shell instance and there is no Kube API server running on localhost. So I told gcloud compute SSH to execute out on controller 0 to run kubectl get nodes, and it works. Now our next thing, and the last thing we're going to do in today's session, is make it work on our Cloud Shell instance. So we're going to configure kubectl for remote access. This looks a lot like generating the kube configs for the various services that we did in Lab 2, because that's exactly what we're doing. We're going to generate a kube config file for our admin user, and we're going to put it in the default place, the default location for our Cloud Shell instance. So the first thing we have to do, and this should look really familiar if you remember stuff from Lab 2. It's kubectl config set cluster Kubernetes the hard way to use my root CA certificate for my CA. I want to tell it to embed my certificates, and I want to tell it to hit that public API, my load balanced IP address. All right, so that's done. Then I want to tell it which user I want to authenticate as. So set credentials, I want to authenticate as the admin user, which is that default super user we get with Kubernetes. I'm going to use the admin certificate that I created back in session 1 and the admin key that I created back in session 1. That's done. And then I want to create a context for my cluster. I want to tell it where the cluster lives and all that stuff. And then I want to set my default context as the one I just created. Now, all of this stuff actually happened. Let's make sure it's functional. And then we'll take a look at the file we just created. So at this point, I am now talking from my Cloud Shell instance to my newly created API, my newly created Kubernetes cluster through my load balanced IP address. That's pretty awesome. So where this ended up, in my home directory, the .kube folder config, here's all the stuff we just set. So here are all of here's our certificate authority. Well, this is actually for a couple of different ones. So here's Kubernetes the hard way and all the stuff that I've set for that. So I'm telling it, get nodes. There they are. Because I'm not running any services yet, because my control plane is not actually running in containers. I don't have any pods running, and that's what we're going to do next week. But at this point, I have a fully functional Kubernetes cluster, except for DNS. We're going to get to DNS next week. Should be pretty cool. So at this point, we've got all of our encryption working. We have all of our services running. We have the ability to talk from our sort of our Bastion host or our Cloud Shell or whatever you're using. We've created a config to allow us to authenticate as that user from that system. We can actually move that config around now and export it out to a file and move that file anywhere we need to talk to our cluster. We have a functional Kubernetes cluster at this point. It's a lot of work. It's a lot of really tedious work at the end of the day, which is why I'm really grateful for tools like KubeADM or KOps or Minikube, all of those things that have that up and running. I think it's pretty slick. So next week, what we'll end up doing is we'll get the routing set up for our pods to let them talk to one another easily. So if we deployed apps right now, the pod routing wouldn't quite work right. So apps wouldn't work. We're also going to set up DNS. DNS lets service discovery happen. So we're going to be in good shape there. And then those are our last two configuration steps. Then we're going to deploy some apps and make sure that it works. And then we're going to clean up our cluster. We're going to take all that work and we're going to blow it away inside GCP so we stop running up our bill. So thanks a lot. This was easily the most complex lab we've had so far, with getting all these services running, getting all these configuration files in the right place. We're clocking in at almost an hour of continuous work to get this done. That's putting us in at about 3 hours, all told, from the 3 lab sessions, or about 2.5 hours from the lab sessions from session 1, session 2, and today's session. So we're about 2.5 hours of pretty well prepped work to get a Kubernetes cluster up and running. And we're not quite ready. We don't have service discovery or routing figured out quite yet. That'll be in our final session next week. It's gonna be next Monday or Tuesday. And in the meantime, let me know if you have any questions. Give me a shout on Twitter. Give me a shout if you're at Google internally. Send me an email. All of those things are very easy to find out in the world. And thanks a lot for hanging out. Have a good day.